All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Dhagash Mehta. He's a senior manager, investment strategist, machine learning, and portfolio allocation at Vanguard. Please join me in welcoming him to our virtual stage.
Okay, thanks very much, Patricia, and thanks very much, AI for 21 Finance Summit for inviting me to give this talk. So I'm from Vanguard Group, the mutual fund company based out of Malvern, Pennsylvania. I should first say this disclaimer: this work is mainly based on my own pure research, and my views are my views, not Vanguard's views. So I'm going to talk about a cool application of machine learning and specifically graph machine learning, which is even newer and even cuter and cooler thing in machine learning these days in the investment management industry. So more specifically, I'm going to talk about application of machine learning for the mutual funds and ETFs. Okay, and this work is done with the help of two of the amazing young and bright data scientists slash engineers, Dhruv Desai and Vipul Satone, both at Vanguard. Okay, so I'll start with this question, which is fund similarity. And what is fund similarity? So first question that I'm interested in is, in general, given a product, what are other similar products? Okay, so if you already have some product, what are the other similar products? The same question, probably in a different flavor. How similar are the two given products? If you have two products given to you, can you come up with some quantitative measure to come up with some similarity? So how similar these two products are, okay? Or how different they are. Product similarity is known in different names in different businesses, such as peer analysis, competitors analysis, and so on. And sometimes you just know it by the same name, product similarity. It's a very frequently arising problem in most business areas, not just finance industry, but in many different areas. You might have already seen some recommendations from Amazon. If you have bought some specific product, it will start recommending some similar products. So similarity. Similarly, in Netflix recommendation system, once you watch a movie, it will start recommending some similar movies to the one that you have watched. In our case, what is product? In my case, the product is a mutual fund or ETF. I'll just call mutual fund just to use it as a generic and colloquial word. I'll not distinguish between mutual fund and ETF for the purpose of this talk. So in our case, when I say product similarity, I'm interested in similarity of mutual funds. So given a mutual fund, can I come up with some top 10 most similar mutual funds or ETFs? And then, if I have two mutual funds, can I compare them side by side with a specific strategy, specific methodology, and some quantitative measurement? So what are the applications for such product similarity tool? If you have some hypothetical tool to measure this product similarity, what can you do with them? So before going to the details, I want to motivate this problem. And here are so many applications that I could think of, but there might be many more. First is, say, sales and marketing. If you are a salesperson and you go to your end customer, see some specific mutual fund of your competitor's company, you can then run this product similarity tool and come up with the most similar fund that you have in your portfolio in your company, and recommend this fund to your end client. You can argue that this is similar fund, meaning that the client will not lose risk return profile that they already have. It's just that your company might have better brand name, better reputation, and so on. Second application is alternative portfolio construction. If you see a portfolio of mutual funds, a fund of funds with all mutual funds in it that are your competitors' products, then you can try to replace all these competitors' mutual funds with similar homegrown products. Again, with retaining the same risk and return profile. Third application is portfolio diversification. If you have multiple different mutual funds which are very similar to each other in the same portfolio, it might be probably unintentional, but you are having this very similar mutual funds in the same portfolio. And then it means that you do not have as much diversification as you think you have. So once you run this similarity tool and then come up with some better fonts to replace the existing ones and have better diversification. Another fourth application is, say, you can come up with some similar fonts to the one you already have, but with a specific theme. For example, ESG, the environment, social, and governance group. Okay? So you can tweak this font similarity tool, which can give you some thematic font which is similar to the existing ones. Fourth one might be competitors, or fifth one might be competitors analysis. So a fund manager can compare various aspects of their managed funds with similar funds managed by competitors. So they always want to be sure that their funds that they are managing are very competitive to their competitors, okay, to their existing competition. So for those purposes as well, this kind of hypothetical fund similarity tool can be useful. Tax loss harvesting in certain countries, and most certainly in the US, you can sometimes sell your mutual funds that is not to realize loss at the end of the year. And then immediately you might want to buy a very similar fund, again, to just retain the same risk return profile of your portfolio. So this is called tax loss harvesting. It's better to realize loss sometimes for the tax purposes, and this tax this then gain can be harvested into other funds. So that's also a very unique application of this kind of hypothetical tool. Launching new products. So let's say you have found that certain fund is picking up very rapidly in the market, but your own company does not have a similar fund to that one. And in particular, this similarity tool told you that there is no really closely similar fund to the one that you are investigating, meaning that there is a gap in the market or gap in your company's portfolio, and it might prompt you to launch a product. So here, instead of using the similarity, you are talking about dissimilarity. That if you see that the most funds are dissimilar to the one that is picking up, then there is a gap here for your company to launch a product in. There might be many other applications as well for this product similarity tool. You can be even more creative than I have been so far and come up with very novel application. But let's move on to some existing methodologies to compute this product similarity. So because this is a very applicable problem, it is coming from business requirements. People have been thinking about this problem for quite a while now, and they have come up with several solutions. The most traditional one is the so-called categorization of mutual funds. So all these different data vendors also have their methodology to come up with to compute categorizations of all the mutual funds. So if you have say a few thousand mutual funds in the US domicile market, uh, Morningstar and Lipper and many other data vendors have categories assigned to each and every mutual fund. So eventually, when you are trying to identify a similar fund to the one that you are investigating, all you need to do is to check this Morningstar or Lipper category of your favorite fund. Go to the lookup table of this Morningstar or Lipper categories, and just list out all the mutual funds which are in the same category as your favorite one. Okay. So then this list of mutual funds which are in the same categories would be, by definition, uh, similar funds. Okay, so that's one concrete way to come up with similar funds, and it has been practiced widely in the industry. The second approach might be a bit more rigorous and probably more homegrown. So you can try to come up with some measure of similarity, such as Jacquard index, weighted Jacquard index, and so on, which essentially just compute the overlap between two portfolios, between mutual funds portfolios. Okay. So these are some mathematical um, uh, quantities to compare two different portfolios. And then you can go from there. Then you can create your own lookup table to compute this similarity. The third option might be to compute not Jacquard index or weighted Jacquard index, but the Euclidean distance. So here in this particular world, you are defining similarity of two mutual funds by just saying that you are computing the Euclidean distance between these two mutual funds. So in other words, you are saying that if you know all the aggregate level information or all the characteristics of individual mutual funds, then if the number of dimensions of this or if the number of all these aggregate features or aggregate variables is n, then each mutual fund is just a point in this n-dimensional manifold. And then you are just computing the Euclidean distance between any two mutual funds when you are talking about similarity. Okay. If the distance between two mutual funds is smaller, then they both are more similar, as opposed to a pair of mutual funds between which the Euclidean distance is larger. Okay. So there is more mathematically rigorous definition of similarity, Euclidean distance, as opposed to say Jacquard index. But you can also come up with some even more refined version of this Euclidean distance in very high dimensional space, and that is cosine similarity. Okay, so instead of Euclidean distance, you can compute something called cosine similarity. many other unsupervised machine learning techniques, such as unsupervised clustering, have been also applied to this problem of identifying similar mutual funds and ETFs in the past. And to my surprise, the literature on this aspect, even specifically machine learning, goes back to all the way to 1997 or so. Okay? So all the way in 1997, someone was thinking about computing similarity of mutual funds using machine learning. That was amazing to read and to put myself in their place and so on. That was amazing time travel. Most of these traditional methods have their problem. So first, all these Morningstar and Lipper categories are, of course, a work of very highly advanced and expert people in economics. But this also partly relies on qualitative approach. So there is always some committee of experts that decide on specific category assignment to a specific mutual fund. Okay, so there is inherent human bias to this whole methodology, and sometimes it is good, sometimes it is not. So it's open to debate, but it does have some qualitative approach and some partial black boxness in the decision making process. Sometimes people have also found that certain categories might not be reproducible given all the data. So if you just do some data driven approach, you might come up with some different categories than the categories that this expert committees have assigned to specific mutual funds. Most importantly, though, in this case, even though if you believe that all these categories are fine, or everything is to the dot, the problem is that if you are trying to identify top 10 most similar funds, for example, that's not what you are going to get from these categorizations. What you are going to get is a list of, say, 100 funds, all of which would be similar to the one that you are investigating. But out of these 100 funds, what is more similar to the one that you are investigating than the others? Or in other words, the ranking will not be obtained from these categorizations. Okay, so that's a severe limitation. The second point, this compute Jacquard index, it captures bigger picture, but really eager to learn more about this differences and similarities at a more granular level. This might not be the right approach. Euclidean distance captures linear relationship, but non-linearities are going to be very difficult. So similarly, cosine similarity, it captures linear relationship among different aggregated variables, but not specifically non-linearity. And the same is case for the existing literature on machine learning applied to this mutual fund similarity computations. Okay? And sometimes they also don't scale well. So there are all these problems that I found, and that prompted me to come up with my own methodology. And here was my idea. So reformulate the data of mutual funds and their underlying assets as a network. And the word network you might have heard from social network and power network, computer network, and so on. It is exactly the same network that I am talking about. I'm visualizing mutual funds and assets as a network. And I'll show you what exactly I mean. Okay, so take it easy. Once I view this data as network data, Then I can go to graph neural network techniques, graph machine learning techniques, and identify a lower dimensional representation of the whole big data set, in which the similarity computation would become easier in some sense. Okay? And once you have that lower dimensional representation of this big high dimensional data, your definition of similarities and your Euclidean distance and many other things are much more well defined. It captures non-linearities, and all these problems are mitigated. So let me show you what I mean by representing mutual funds and their assets data as network. So let's say you have, for one particular snapshot in time, the mutual funds data in this tabular format. So here I have in rows, I have fund 1, fund 2, fund 3, fund 4, and so on. And the columns are asset 1, asset 2, asset 3, asset 4, and so on. Let's say Google stock, Amazon, Facebook, and so on. The entries here in this table corresponds to the weight of this individual asset in the particular mutual fund. Okay, so for example, fund 1 has asset 1 in it, and its asset 1's weight in mutual fund 1 is 20%. Okay, and so on. So that's all this data tells us. Let's imagine you have this data for all the index equity funds and ETFs. Index funds, to make it cleaner, I didn't want to introduce bonds and many other complicated assets here. So just to keep it simpler, I just used equity index funds. There were total 16,000 assets in total, and some 1,100 or so equity index funds. So that's my data. And for all this, I had, which means I had 16,000 times 1,100 matrix or table. Once I have this table, I did not want to use this table, but I wanted to create a network out of this table. Okay, so here is what I did. So all these fund 1, fund 2, fund 3, all these rows, I put them as circles, red circles here on the left. And on the right, I put asset 1, asset 2, asset 3, and so on as blue circles. So these are my so-called nodes of the network. Okay, and then I also have put links between them. So fund 1 is connected to asset 3 if fund 1 contains asset 3. And then I also put the weight of individual assets in particular mutual fund. Okay, so eventually I have this network structure. It is called bipartite weighted network. Okay, so instead of this tabular data, I created a network out of it. And then I can use all these existing technologies to investigate bipartite weighted networks, and especially machine learning techniques for graph networks or network graphs. Just if you are curious about the full graph that I had, this is the best I could come up with. This is bipartite network. The inner circles are all the mutual funds that I had, and the outer circle is made of all the assets in all, so 16,000 or so assets, and there are many different links between them. Okay? This might not be very helpful, but it's a nice representation of the tabular data. Okay, so okay, and this is for the simpler case where I have just 8 or 9 mutual funds and there are some assets in it. It's just a sample of that. So once I have that, my whole problem of computing similarity becomes a similarity computation on networks. So for example, on network, this node 1 is similar to node 2 because it has the same number of nearest neighbors. Similarly, node 1 is similar to node 3 because it has the same number of next to next nearest neighbors. There are different other quantities as well, which can tell you more and more things about similarities. Eventually, I used a sophisticated algorithm to compute this similarity. And this algorithm is coming from graph neural network technology, and specifically it's called non-2Vec. Okay? So very quickly, and I know I'm running out of time, so very quickly, a non-2Vec is essentially just computing a low dimensional representation of this big network data, where all the actual similar data points would remain close to each other, and the dissimilar data points will become farther from each other. So eventually, I used non-2Vec for mutual funds data, and then I computed all the similarities and created this similarity toolbox. So that's I wanted to mainly emphasize the applications of this Fund2Vec tool rather than the actual technical details, because this is supposed to be a business track talk. But if you have any question about technical details, please feel free to reach out to me or any of my co-authors. And I would like to thank AI for Finance Summit, Patrika as well again, to give me this opportunity to showcase my some cool work. Thanks very much, Patrika.
Thank you so much. Thank you for sharing these insights with us. We really appreciate all of your awesome knowledge that you've shared with us today. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure to accept your connection request and check out our awesome AI exhibits. Thanks so much, and we'll see you around.